Good morning to you all. We are here to welcome you to the second edition of the Porto Tech Hub conference. And I would like to also present the team that made this conference possible this year. Well, at least part of it. Rui Barreira from Critical Software, Paulo Faria from Critical Software, which is me, Ana Souza from Farfetch, Luís Ribeiro from Farfetch, which is in the check-in spot, and persons from Blip that I can't see, that should be here on stage, but a special thank for all of them. One thing that I would like to emphasize before handing over the presentation to the mayor of the city is that this is the second tech conference, but Porto Tech Hub is now an association, a private non-profit association of tech companies that was founded by Blip, Critical, and Farfetch, which are three relevant tech companies established in Porto. The mission to the association is to promote this amazing city to work and to live as a tech hub, a technological center for excellence and innovation from this city to the world. The association started with 3 companies, but there are 2 companies that already joined the association, which are Critical Manufacturing and Buyside, and we have a call for new associates open. So if your company copes with the mission of the association, just contact us and we'll be very happy to start conversations and to understand if you are in the place to join the association. Just to finalize, and this is very important, we have a strong institutional partner, which is the City Hall, Porto City Hall, and we are very grateful and we thank to the mayor of the city, to Filipe Araújo, City Councilman for Innovation, from City Councilman for Economy, Ana Teresa Lehmann from Invest Porto, Paulo Calçada from Scale Up Porto, and a lot of many other persons from the City Hall. Of course, a special thank to the organizers, the 3 companies, and the volunteers that are struggled so hard to make this presentation, this conference possible. Of course, the sponsors and the partners, very important to set up a conference like this. The speakers, which will be entertaining you and sharing the knowledge and all the experience they have with you. The companies that let them go, that let them come to this conference to share the knowledge. And of course, the audience, thank you for attending this second conference. Now, I'm calling to the stage the mayor of the town, Dr. Rui Moreira. O microfone de lapela.
Okay. Well, good morning, everyone. I would like to greet the representatives of the founders of Porto Tech Hub, Blip, Critical Software, and Farfetch. Also the new members, Critical Manufacturing and Buyside, the speakers of the conference, the delegates, well, everyone welcome. Let me start by welcoming you to our city of Porto, a city known for warmth and hospitality of its people. Also to this room. It's a special room for me. 3.5 years ago, nobody knew about me, or very few people knew, and I came here with some of my friends, and we said, we want to run for the city of Porto, and we won the election. So you understand, every time I stand here, it's more comfortable now than it was 3.5 years ago, but my heart still beats a little bit. But let's go back to the main theme. What we want to be known for, so much more than that you are helping us in conveying the right message. This right message emphasizes Porto as an excellent location to live, to work, and to invest. This is a city that has an incredible talent pool, fantastic universities and state-of-the-art research centers, a vibrant ecosystem of startups, which you all know, scale-ups, and larger companies, so many of them represented here today. Last year, I opened your first conference when Porto Tech Hub was still a dream of 3 extraordinary companies. We had hundreds of delegates, and your event was a success. Then, magic happened again, and here we are today, with the association being already a reality, with new members and several other exciting companies interested in joining this bandwagon of believers in Porto as the place to be for high-tech investment and as a location where talent can thrive and grow. In the meantime, we had the fabulous news that 2 of your founders were investing in Porto, Blip, in a considerable expansion due to open at the end of this year, and Critical Software, who is moving in next month. So much happened in a year. Through Invest Porto, it has been a pleasure to work with you to stimulate the attraction of investment to our city. Not only in the important already mentioned cases, but also in helping us to convince other investors to come to Porto. Some of you were with us in the front line of the negotiations, being credible witnesses and in some cases ambassadors of our city, and helping us to win with several centers of excellence, some not announced, some already known, like the Global Center of Euronext. I also thank you for your help and working with us as partners of the new initiative launched by the Minister of Science, Technology and Higher Education, geared to advance and promote the skills needed in the future, notably in increasing the supply of courses related to the digital economy. Your input is decisive for the best possible results in designing and implementing appropriate training needed by the industry, by the many companies in the software sector that are located in Porto, both large firms and small startups, national and foreign-owned. You are also the inspiration for the Scale Up Porto program, showing that Porto has all the conditions for startups and for them to scale. This program consists of an important commitment to consolidate the city innovation ecosystem that can be reflected all over Europe. Scale Up Porto aims at becoming a catalyst. Murder. And it's not my phone, I left it somewhere. You are also the inspiration for Scale Up Porto program, showing that Porto has all the conditions for startups and for them to scale. This program consists... It's Scale Up. Okay, let's try and shout. Scale Up Porto aims at becoming a catalyst for the growth of that ecosystem and a network of individuals and organizations that share the vision of a Scale Up program. We count on you also to make this city an ever more cosmopolitan locus of talent and initiative, to bring people from abroad to live, work, and invest. This is a strategic question for us. I'm so glad to see that you did it again, having a sold-out event with over 650 delegates in this second conference, with speakers from world-class companies like Google, Spotify, IBM, among others. Let's hope some of you from outside Porto will be tempted to come back and to spread the message of the vibrant energy I hope you will feel here. This event is living proof that our best companies are our main advocates. May I finish by saying that, again, I'm very grateful for this initiative, for all that Porto Tech Hub is doing, that is so important and highly complementary to our policy of economic development of our city. Thank you all for coming to our city. I wish you all a pleasant and very productive event, and also a good stay in Porto. Enjoy the city. Thank you.
Hey, hello everyone. Welcome to Porto Tech Hub Conference 2016. My name is Nuno Gouveia. This is Rui Lima. I'm Rui Lima. Yeah, we're going to be your hosts for today. Rui, please welcome people.
Welcome to Porto Tech Hub.
Queres o microfone?
Penso que sim, né? Quer dizer, o microfone ou...
Só há deste.
Okay, so obviously Rui stole me the mic. That's cool. Let's thank you. So let's welcome our first speaker to the stage. He's a software engineering director at a very small company called Google, and please join me in welcoming him to the stage. Everyone, Acácio Cruz.
Testing. Good morning. My name is Acácio. I'm from Google, I work in Zurich, but I'm actually Portuguese. Bom dia. É um prazer estar de volta no Porto. Já não vinha cá há 15 anos e está remodelada, está muito bonita a cidade. Sorry. I'll switch back to English. Actually, my Portuguese is slightly impaired since I've left Portugal for 15, 17 years now. So I am what the Portuguese call a camon. Yeah. So there you go. I actually asked the presenter, the organization, if I should do it in Portuguese or English, because that would be a problem if I had to do it in English. In Portuguese. Anyway, this is a technical talk, right? This is a technical conference, so we're going straight into technology. I am very pleased to see many women in the audience. Google is a very big supporter of diversity in tech, and Portugal really is making progress in there. So welcome to all the women in the audience as well. So, load shedding. So why are we here to talk about load shedding? By the way, who knows what I mean by load shedding, or, hands in the air, load shedding? Ooh, okay. So, this is why. 2009, so I joined Google in 2007 to join what's called Site Reliability Engineering team, which is the team of engineers focused not in operations in the typical operational model, but operations in the sense of Google model, where engineers take care about reliability, they focus in system architecture. And I joined the Gmail team, actually. I brought Gmail to Zurich, to Europe. It was just supported out of the US. And then 2 years later, this happened. In fact, 2009 was a very bad year for Gmail. We had 3 Gmail global outages. One of them around 20 hours, if I remember correctly. Those days are a little bit of a fuzzy. And then, I was inadvertently in the covers of newspapers, right? And that was not a good moment. Fame that way, that was the first takeaway, that when you manage a big service like that, fame is not a good thing. And out of that came a stream of work that my team led, and then we've been working on this since then in what we call load shedding. Load shedding basically is how can a service handle load to their maximum capacity But then, after that point on, basically ignore, shed the load, basically ignore it, send it away. There's many mechanisms, but that's basically the ultimate principle. It sounds simple, it's not simple. So the timeline was in 2009, as I said, there were the 3 Gmail global outages. We had, in 2010, a first implementation that would actually be able to handle overload mechanisms. And then we start generalizing it, and then it became deployed in many services. And now we actually are working on standard modules that we can just deploy in any service at Google. In fact, I just left as a reorganization a few months ago. And what we're doing is working on software infrastructure and deploying this across all of the systems. And it has immediate impact. So the agenda, we're going to talk about a little bit of load sharing, what it is, what are the threats to services, and then the impact in service management and how you should, how it impacts your service. I want to put a little bit of a parenthesis, because you might think, oh, these guys from Google, they have a ton of machines, it doesn't apply to my small service. And I want to dispel that notion, because in fact, Google is actually more able to handle, and this is one of the reasons why we, at some point, were less prepared in the past, because we had a lot, you probably heard that we have a few machines, So it's relatively easier for us to handle, for instance, an increasing capacity or a product that is more popular than estimated, or an attacker just by throwing hardware at the problem. We have a very nimble infrastructure. So if you need to find, say, these are all make-up numbers that I'm going to say in this presentation. If you say, I need 10,000 machines, they will show up. If you're a smaller service, smaller company, you don't have that luxury. So that means that your service surviving at a smaller scale is even more important. It's your company's life that's at stake. If your customers can't use your service, your service is by definition dead, which in some cases that might mean that your company is dead, right? So it's even more important for a service to survive. So threat number 1, at Google, the intern. When I started, we used to say that we actually had the intern denial of service, because we bring an intern and then we give them MapReduce, and then we give them several of these clusters with tens of thousands of machines, and then the end result is an intern distributed denial of service. So intern threats, this is a little bit of a joke, but don't ever underestimate the potential for destruction for your own staff. So what sort of threats do we have, right? We have attacks at the task level, at the process level. And here can be the typical bugs, can be a machine, can be bad software. For instance, in Java as well, you can have garbage collection, all the garbage collection languages. So there's stuff that happens at a task level that may cause that task to just be overloaded, overwhelmed, and crash. In our case specifically, we also have things which are cluster specific. Because we have a job, a service is distributed across many clusters, and traffic comes from many clients, and some clients are present in only one region or one cluster. So suddenly, you can have a service that globally is fine, but one cluster is overloaded just because of a regional nature of the traffic. This is something that happens. But generally speaking, the biggest attacks or threats are, service-wide. Typically an antagonistic, player, there are a lot of hackers. There's, for $20 you can buy attack script kiddies from Argentina and get a bunch of, I think now the rate is $200, something like that, for 5,000 PCs that you can then command and operate, and you can attack everyone, right? So almost everyone now has gigabit, at least in Portugal, is the internet. And I think people underestimate the damage and impact that a antagonistic player can have in a service, any service. Even with a single PC nowadays, with a gigabit internet, you can attack and effectively impact any service. So you cannot just ignore this aspect. But then there are also internal causes, right? Bugs, For instance, one of the typical examples is if you actually send the client with JavaScript that does like reloads, and all of that is not a deliberate attack, it's not an intentional attack, but will impact your system. And one of the best areas, but also what at Google I used to call failure by success, which is if you are lucky and you ship out a product or do a launch that is very successful, and then 20 million users arrive and your infrastructure is not able to deal with it. Failure by success is actually a big threat. So how do you survive these moments? So just a quick shout out. At Google, an application is effectively a stack of things. When we say an app, let's say that the green box there, there's a front end, there's back end typically. We do RPCs across the stack, remote process calls, procedure calls, and we do load balancing every single layer. Right? So every application is that, and then it calls a backend or a storage. Those backend and storage boxes are again boxes like that with many layers, many complexity. So it's not unusual when you go to a Google box property that you click on something and that traverses 10, 15, 25 services. Okay, so it's a tree of services. And return the response in 250 milliseconds max, which is the window for responsiveness, right? So our strategy in applications is make sure that we do load balancing in every single layer, not just at the front-end layer, which is what the industry typically deploys still these days. This was actually captured then at midnight or something like that last night from a real service. The outages that I mentioned for Gmail were, in two of the cases, caused by the service that this service here represents. This is the service that has your account details, first name, last name, service bits, picture, profile, all of that at Google. It has a lot of requests per second. That X is a very big number. And you see there's a pattern there. In fact, you can even detect Saturday and Sunday. So at scale, services have a very homogeneous, I would say, predictable path. So what happens is, I have scientifically modeled it at that sinoid. That's the traffic rate of a service. And then at Google, we use containers. So what we do is we do CPU reservation. In your case, you probably have machines directly. Now people are playing with Docker, but it's basically the same concept. We know what the traffic rate is going to be. There's a safe allocation just for something. That margin is a margin of error, but that margin costs money, right? Because it's basically free hardware that you bought that is doing nothing just in case. And the more margin that you put there for safety, the more money you're spending. And nowadays, we know the startups are very lean, so the tendency is to go leaner and leaner to lower that safety margin. And what happens is when you have an outage, effectively, from an abstract conceptual point of view, is some of that computing power went away, and right now your serving capacity is below what your peak traffic can be, right? So you might be lucky that it can be a trough, at the bottom end, and nobody sees that, but you might also be unlucky, it's at peak. For instance, that Gmail outage where we were out many hours was at peak, which, by the way, that curve, if I may, that the peak is between 3 and 6 p.m. Zurich time. And that's the combined usage rate of all the people in the world that peaks there every day at the same time. So, questions at the end, but if I'm going too fast, please let me know. There's another aspect about performance that people rarely talk about, which is a task, a process does not have a linear performance curve. Typically, what happens, there's a sort of a flat performance until the task starts to becoming overloaded, either by contention in the software or contention in the CPU. And then there's this very famous hockey stick curve, where performance just increases. And then you have high latency, becomes very slow to process the requests. You don't want to be there, but one of the things that is actually rarely spoken about is actually if you continue at that stage and beyond, which is the overload scenarios, most cases tasks will die. Your process will die or will become so slow that they are effectively not processing, and then at that point there is no difference between a stopped task that can process and a dead task. You simply have no serving capacity. And that's where things start to go bad. Because as soon as you lose processing capacity, effectively, of one task, of one process, that request traffic, because nowadays we build stacks with redirectors, traffic directors, load balancers, that traffic always goes to somewhere. This is like a river. Water doesn't stop flowing. They always come. During the Gmail outages, Gmail traffic tripled because people were like, oh, my Gmail is down. Let me reload. Hey, your email is down? No, I don't know. Let me check. Reload, right? So it got worse, right? And as soon as you lose one task, that traffic goes to the other tasks, which then were all overloaded. So they become even more overloaded. So some of them are going to die. So at that point, that traffic is going to the other tasks, which are going to become even more overloaded because less of them available. And then they'll start dying. And this is what happened in 2009 without our user data moves bug. And then we had a data center that went down. And then we lost one data center, and then we lost two, and then we lost three, and then we lost all of them. So the key message is survive. Survive at all costs, preserve some computing capacity. Over the years, we actually developed a set of principles that we are working on, and how my team actually applies in the software. And one of them is sustained peak performance. So if you go back to that hockey stick curve, apologies. What we want is to keep the tasks at that level, that peak performance. And to monitor itself so that it keeps there, and if it keeps getting more traffic, then regardless of what is coming, just don't do anything. Share that load, cut it, fail fast. So that's principle number one. Another principle is about isolation. This doesn't apply to all the service, but if you have a service that has more than one client, and when I say client, I don't talk about end user, but imagine that you have several top-end customers that use your service, you want to make sure that a misbehaving client doesn't impact another one. This is very important, especially if you have paying clients. One area that we actually worked upon is actually request QoS. Not all requests are born equal, so there's some room for play if you actually have applications with different priorities. Work conserving is a concept that we use, which is even if you do all of these very conservative tactics, but if you come to the conclusion that your task is safe enough to handle a request, handle it anyway. So don't throttle when you don't need to. Another change that happened with our infrastructure was when Google was created and launched search. Search is a very uniform cost service. The way it's done, to be predictable, to be fast, all queries have a fairly limited range of cost. But then we went into new products. We went into new areas. And all our tooling was based on the search concepts. But then when I was working in Gmail, if you're loading a PDF of 20 megabytes, of course it's going to take more time than if you just load an email with 4 or 5 characters. Different costs have, different requests have different costs, even though if it's the same service. And then when we did social, started doing social, even the data model is completely different. I have no friends, so getting the list of my friends in G+ is very fast. But if you try to do the same thing with Lady Gaga, I think the last time they checked is 9.5 million. So if you order list of friends of person X ordered by affinity, with her is very expensive. So we actually developed this concept of cost base, and cost base queries literally translate to CPU utilization. Another aspect that we have been working on, is actually very relevant, is retries. A lot of software on the client side, when it fails, and that's what happened when you actually, on the server side, you throttle a request, it fails, even though there's some semantics there. In most clients, retry immediately. And this happen, if this happens and it's not done carefully, is yet again worse than if you actually didn't do any throttling, because then the client is actually going to bombard your backend. So retry policies are actually very, very problematic if not done correctly. We've had a lot of problems like that across many of our services, where retries were done naively, and some things can get really, really nasty. And another thing that we did was something more internal, which is we take up the policy for mechanism. This means we measure in one way, and then we apply the verdict, the throttling or the decision in another way. We actually split these two parts, which allows us to implement different policies, different mechanisms, and I'll give a quick glimpse on that afterwards. So this is a quick run through. Sustained peak performance, as I said, always maintain the task at peak performance level. And nowadays, I'm happy to say that our, what we call utilization levels, we have some services which are CPU intensive, and we can get 80–90% utilization in a job. I don't know how many, how many of you actually pay attention to your CPU utilization, but I remember in my IT days before joining Google that utilization was typically under 20%. Most people don't ever run their machines hot. At Google now, we're, because at our scale, this is many, many, many millions of dollars, running it very hot, but safe, means that we're saving a lot of money. And so above all, don't crash. Isolation, I mentioned. One of the things that we do is actually we keep an eye on what we call organic growth of quotas, and every quarter, if we see that the growth of traffic per client is organic, we just manage that automatically, no bureaucracy. Request QoS. I'll go straight into the graphics. What we found is inside of that traffic request, not all requests have the same importance. So if you are in Gmail, a lot of the things that you see there are widgets. If the widget doesn't work immediately, if you don't have serving capacity, it's less important. In fact, that was one of the outages, was the context system was down, and the context widget would not load, and therefore the whole Gmail application would not load. And one of the changes that we did there then was actually make that widget optional load, which means that if you're under pressure, you can actually say, this request is less important than that. So I'll shed, I will not actually serve this. So if you start looking at that approach, typical example is background refreshes of data that you have in your screen nowadays with React and all of those more dynamic applications, single page apps. You have a lot of these transactions, and they all look the same if to your service if you don't plan ahead. But if you start looking at from a functional point of view, okay, what is my main app? What are the optional widgets? What is my batch traffic? You can then say, I actually have a hierarchy of needs. And then, when you have an outage, which I mentioned before, then you can do something like that, which is you can prioritize and serve based on the request priority. And the end result is you're still having an outage, you're still not serving part of the traffic, but your user doesn't notice it because you're serving the important parts, right? The important bits of the application that the user cares about. So just thinking about how you can actually classify your traffic in different categories and take away what is optional or secondary. Work conserving, I mentioned about, despite all of being this very conservative in terms of sharing the traffic, if at the end you make a verdict that's saying that my task, my process is actually able to serve this, always serve the traffic. Cost-based I mentioned before as well, retries. Just an initial mention again to the retries. Mobile is specifically a problem here because, especially now with LTE phones, the networks are getting better. If you don't do retry logic in your mobile app, it will, seed a wasteland of overload in your backend services. And this is non-trivial matter because there's a logic in your app, then there's actually the network stack in the mobile phone actually requires quite a bit of testing and thought. And what we've done as well is actually focused load shedding in two areas. I've been speaking until now mostly around server-side, but we do server-side throttling based on a lot of these policies and making sure that we do like very low impact on latency. All of this needs to happen, all of this computation, but needs to have very low impact on the serving of the time of the request. So we cannot, I can give you an example, we just implemented this in a service that handles the signing keys for the storage, for instance, that all of our data is encrypted. You probably heard about some revelations by Snowden. So everything is encrypted. And we have a service that actually has the signing keys. So this needs to be very low latency due to this as an impact on storage. And so we're talking about microseconds, right? Even for an RPC. This is our service that they need to return in 1, 2, 3, 4 milliseconds max. So the impact of load shedding in all of that very fast service needs to be very minimum, right? But one of the things that we're also starting to work on was also on the client side. Once you have a backend service that is implementing load shedding and is throttling your traffic, then your clients can do something interesting with that information. If you actually signal back when you returned an error, if it's not just an error, if it's just error because the task is loaded, or error because the service is loading, or error because your customer role or customer ID is sending too much traffic, then the client can use that information, right? Because if it's just that particular task that is loaded, it can retry in a different one, and you actually get even faster performance than you expected. If it's the whole service that is, the client is sending too much traffic, then it can self-throttle. If it is the whole service that is, the backend service that is overloaded, then it can actually ease up the rate, and all the clients do this. So then, like easing the overload scenarios. So techniques, we have. This is the area where I can't get into a lot of detail because this is a lot of very, very, very specific detail independent of the platform. But we have many what we call load trackers. How do we measure that a task is loaded? We used to have a very simple model that was the first one, our emergency, based on what we call token buckets. We had based on monitoring, we actually modeled the cost of each request, and then I had a guy that had a bronze medalist of mathematics Olympics, so he did a very nice computation model, but that was not very agile. Nowadays, we actually have several trackers more based on the dynamic state of the task. Some services need CPU tracking, some services need more memory tracking, some services need a combination of all of these. So we actually have we have those different trackers in different languages as well, because Java behaves different from C++ or from Go, which are the three main languages for service at Google. But they all have a core approach, They all compute the task load, in real time, accurately, and they all also compute the cost per request. So it's not enough to know if the task is loaded. It's actually quite important to know which request, which service. You have multiple endpoints in a task. It's important to know, is it find friends, or is it, user profile, or is it what sort of request has the cost, and it's very, very important to keep that. So effectively, time check. So effectively, imagine the load in a task as a band from 0 to 1. we have limits from low priority request to high priority. We start throttling, as the task gets loaded, we start throttling lower priority first, of course. We start shedding a little bit more aggressive to leave some empty room for higher priority requests. Basically the flow is, when the request gets received, if the task is not overloaded, just do the stuff, but it's overloaded, we check if it can be retried, or if there's task limits, which is the limit within the task, and we change the state, and that's when we start actually shedding load. And then there's also, even if it's load that it can serve, we actually check if the service is, a client is above his quota, so that's the feature that enables customer isolation. And the work consulting, even if you go through all of this workflow, but we say, well, but the task can still handle the request, so serve it anyway, right? So effectively, we have a sort of limits. We have soft limits and hard limits. And this is the logic. Like, if it's idle below certain, always serve, don't even check. If it's loaded, serve it has quota. And if the task is overloaded, basically you start, aggressively shedding traffic. By shedding, I'm talking throttling, right? You very quickly just go error, this is the reason, and the task should spend very, very little time doing this. Just before I go, how this changed services and service management. Sometimes you just can't avoid the task to die. So one of the things that my team has been doing is trying to put these in as lower layers as possible in the stack, because sometimes you just can't avoid. If the traffic is handled by a lower layer and it's got overwhelmed by a lower layer before you have an opportunity to actually deal with it, then your task will die. A typical example was about 3 years ago, maybe 4 years ago, JRE7 Java, Sun Oracle changed the algorithm for socket connection accepting, and they went from the algorithm that they n log n cost to an exponential. So, and they must have done the tests, and when you have a task that has 100 sockets, that's fine. But our tasks sometimes have tens of thousands of sockets. For those that are still familiar out of university and the cost function, when you have a cost function of exponential and then you throw a big number as 10,000, basically this was chaos and mayhem at Google. For all the services that were using that version of JRE. And there was nothing we could do because this was so low in the stack. This was at the Java accepting the TCP sockets getting overwhelmed there, that the jobs would die. So you always need, load shedding will get you far, but then there is more. Effectively, what saved us in that particular case was the services on top of those had load shedding and they become overwhelmed. So they were shedding traffic at high level in the stack. So, your team is great, you implemented load shedding, you have some libraries, you deploy your service, life's good. So how does that change your service, your company? So there's 2 things that we noticed. First of all is around, of course the reliability will increase, hopefully, if you've done it correctly. But there's one area that really increases, which is utilization. Remember the safety margin that I mentioned before about provisioning? Well, if you know that your service can survive, little task overloads, you can reduce significantly your spare capacity, your safety margin, the buffer, right? And you know that you can do safely without causing outages. In fact, you can be as bold as even launching services for which you don't have capacity, just to see if they're popular or not, and then buy the machines later if you want to risk, right? If there's no budget, right? Can be speculative of that. At Google, we're starting, with that service that I mentioned before. After the outage, we had a utilization of 25%. Imagine, only using 1/4 of the available capacity. The 3/4 of capacity were just there just in case there was an event. That was a lot of money. And we're now raising at more than 80%. Actually, I think the last time I checked was 85%, and they were going to 90%. Another thing that is actually very interesting is, I don't know how many of you guys have applications or that require batch workloads, but a lot of companies have this, right? We have the serving capacity, which is a nice, sinoid curve, and then there is this batch loads, data transformation, map reduces, Hadoops, all of that, and those things are not, regular at all. They are spiky. Sometimes sales wants a report, and then they just run. There's something that runs periodically. And of course, those things also need machines, and also need not to crash, and there's safety margin. So basically, all the white around that is wasted hardware, wasted money. So how can we actually use this? So one of the things that we do is, this is the normal traffic pattern, as I mentioned before. What if we can merge, right? So if you have request QoS, request prioritization, and you can tag the batch traffic as lower priority, so you can actually safely merge. And at Google, we used to have usually production stack and the batch stack. And that's one of the things that we got rid of with using load shedding, is because now that we know that we can handle service being overloaded, well, we'll overload it, right? And we overloaded with using our own internal traffic. And what happens is, during the trough, the days, at the end of the middle of the day, when nobody's using the service, well, nobody, a few million, but less 100 million than usual. There's all of that spare capacity. So those machines can then run all the map reducing fast instead of another set of machines. And if by any chance traffic combined exceeds the total capacity, what happens is load shedding will first defer all of that low priority traffic, and it gets done later. That's what we mean there by the deferred batch workload. So your batch jobs will take a few more minutes to run, but that's not important because they still run and you're still saving a lot of money. And you can play with this safety margin down to 0 if you want to, right? So that was batch handling. And the third aspect is something that we're still exploring. So one of them is actually in the teams management. As I said, I was managing many SRE teams. I created about 17 SRE teams in my SRE tenure across the service. One of the things that happened when the service got load shedding, you immediately change the nature of handling this. We have pagers, and people usually there's one engineer that gets paged when there's a problem in the service. Around the world, it's the person, and he can effect all the change that he needs. But if you have load shedding, a lot of the things stop being emergencies because they're no longer outages, and they become mere problems. It's something that you can take a little bit of a little bit more time to inspect the root cause. Latest example was in that service that I mentioned before, that graph, which is the profile system. About a year ago, Google Maps service, they ran a load test on Google Maps at peak time, at 6 p.m. And this was a lot of traffic. And their load testing actually then, of course, queried the profile system because in Maps, you can share with your friends and all of that. So that inspected, that was a lot of traffic. But because we had load shedding, what happened was nobody else was affected. Google Maps got throttled a little bit. And then, one of my guys got a page just because because load shedding for a long time, so it's a suspicious condition. So he looked at it and then talked to the Google Maps, and they're like, you need to fix this. And then, they went and figured out. And they actually found out they had a bug in Google Maps, and then they figured out that they were querying the profile system far too much. And that was a leisurely conversation of 3 days, and during that, the problem got addressed and solved, and then Google Maps got improved. If we didn't have load shedding, we would have had an outage. The mitigation is, throw more machines at the problem. And it would be, we had less time to think about it, less time to figure out what the problem is, less quality in the resolution. So it actually changes the nature of how we deal with issues. And another aspect that, and this is actually the area that I said that we're still exploring, and I'm still exploring because we built this as an exception mechanism. You know, load shedding was built for when the service is overloaded. And that is an exception, that's an emergency situation. But what if it's not an exception? What if you actually then, since you can rely, if your task can be reliable for seconds under overload, can be minutes, can be hours, can be ever, you know. So that opens possibilities. One of the possibilities, as I mentioned before, I hinted, is maybe you can launch a service for which you don't have hardware for. You know, maybe it will be successful and then you buy the machines, or maybe you beat a successor, a competitor to the market. Or, for instance, you can launch an app where you don't have the hardware to serve all the features all the time, especially at peak. And then at peak time, you don't show, you know, a thingamajig, you know, that you can at the peak, at the lower. So if you have different priorities. So you can do stuff like that. That is quite interesting. So we're looking at, you know, where some apps where we can provision below peak traffic, right? So, Q&A. I hope this was useful. I was at the stadium when we won, so I was very happy. Do we have questions in the audience? Should we? Hi. Yes. Thank you. Testing. So I hope I didn't shock you guys with a very technical, there's a question there in the left, with a very technical presentation right off the bat.
Hey, so I'm guessing this is done on a framework level, the load shedding stuff, or the QoS stuff. So my question is kind of a clarification, I guess. You mentioned first that this was done between the downstream and the clients. But on another slide, I guess, you mentioned that you had load balancing in front of all the services. So I guess my question would be, is the load shedding done between the clients, and are the clients synchronized with one another? So do they have the same view on the actual downstream dependencies? Or is this done by the actual load balancer? Or do you assume that the numbers are big enough and that if the services or the hosts running a service are up, the load balancer, the load balancer can respond for all of them as being one?
Okay, so a bunch of questions there. So yes, it's framework, but it didn't start like that. It actually started as just a library that we're deploying one by one services. And then as my team actually has been working on frameworks, so the business logic is separated from the infrastructure, and the infrastructure has a module already as default that implements load shedding. So no, it's not done at load balancer. This is what I'm talking about. This is why we have Java, C++, and now working on Go implementations. This is actually in the binary, because only the binary can know in milliseconds what is actually the load. You know, a load balancer can only check every few seconds, and a second is too late. 1 second is too late. You know, a task will go from okay to overloaded in a few milliseconds. Just as an example, if you receive the request to do sorting of friends of Lady Gaga, that request, you know, it's enough to keep one profile task, you know, busy for a few seconds. And the final question is why, you know, are the clients synchronized? It's a complicated response. Effectively, what we try is for each client to be as independent as possible of knowing the state of the backend. All a task needs to know is what is the health of my backend tasks that I'm connected to. And also, you know, I know most people don't have this problem, but when you have a service that has tens of thousands of tasks connecting to tens of thousands of tasks, you can't have all the client tasks connected to all the backend tasks. Just, you know, combinatorial explosion. So what we do have is one client connects to a subset of the backend tasks. And then if one task dies, then it connects to another one. So all it needs is to have that information of the load of those back-end tasks to make the decision in itself isolated to where it should send the traffic. What the load balancers provide is the list of back-end tasks, which clusters they should send, and that is refreshed every tens of seconds.
Yeah. Cheers.
Anything else?
Hello.
Hi. Hi again.
Hi. So when your slide that had the CPU reservation, where you had the sun as the curve with the traffic, and then you overlaid the batch, yeah. So the CPU reservation is for the actual physical machine, or how do you does the batch is the batch scheduled into the application container? What does that mean?
That particularly means, so we use containers for each job, and that what means is the aggregate job CPU allocation to a specific role. So if we say, profile system, has this many CPUs, and then profile service has this many CPUs, and profiles batch has these other CPUs, and they all go into the same bucket. But then we can actually co-locate those services in the same machine, and then those things kind of lean against each other. Both containers squishing, basically.
Okay, thank you.
Last question, if there's one. No? So thank you for your time. I hope this was useful. Very pleasure, and enjoy the rest of the tech conference. Have a good day.
Well, thanks. Sorry. Thanks, Acacio, and thanks also to Blip's SRE team for making the questions. That was a nice one. So, guys, so I have great news for you, but before that, I just want to say that our QAs found 3 bugs in this paper. But luckily, we do continuous deployment, and we did fix our bugs in the website. So everything about the timetable is okay in the website. There are a few mistakes here. Don't worry. It's Christopher Noring that's not on Tony Room, and Craig Donson that's not going to be here. But don't worry, everything is okay on the website, and we do have free Wi-Fi. And now, you want to say? Yeah, Acacio is saying here that he is going to be on the coffee break. Please be comfortable to ask him any questions. And now it's the coffee break. Please enjoy. We have 3 areas here and 2 outside. 4. We have also in the restaurant upstairs 4 areas. Please don't focus just on this one. Thanks. Hey everyone, hope you enjoyed your coffee break. Now we're gonna have our second talk in this stage, and it's gonna be Sally Goebel. She is head of quality at The Guardian. And I had the pleasure of seeing Sally's talk earlier this year in XP 2016. And I can say it's really not conventional. But the main point, I think, is she's going to bring here to us a brilliant new perspective to testing of web applications. So please join me in welcoming Sally to the stage.
Thank you. Hello, everybody. My name is Sally Goebel, and I'm the head of quality at The Guardian in London. It's not the head of testing, the head of quality. And I'm here to talk to you about what really happens when you deliver software quickly. And really, what I want to share with you is, so I'm from a testing background. I want to share with you how we really changed the way we did testing and quality at The Guardian when we started delivering our software much more quickly than we used to. So for those of you who don't know what The Guardian is, we're a news organisation. We're the second largest English language news organisation in the world. We were given a Pulitzer Prize in 2014 for our journalism, and we have around 9 million visitors a day to our website and our apps. That's about kind of 30 million page views a day. We also release our software 400 times a day across all of our products and across all of our environments. That's not the kind of the text of the news, by the way. That's software updates. 400 releases a day. And in order to support those 400 releases a day, we have 4 automated tests running in production across all of our products. That's 4 automated tests. And the aim of this talk today really is to persuade you that test automation is not a prerequisite for continuous delivery. The reason I want to talk to you about this, and the reason I've been kind of doing this talk, is because I was at a round table event a few months ago with a whole bunch of heads of testing and a whole bunch of companies that were selling software testing services to us. And this guy stood up, and he was a software testing services guy from a really big, internationally known company. And he stood up and he said, you know, the thing is, companies like Etsy and Amazon, they're able to do continuous delivery because they have automated tests in place, and you should buy our automated testing services, and then you'll be able to do continuous delivery as well. And I kind of stood there and I thought, that's strange. That is completely the opposite of my experience. Because in my experience, the more continuous delivery we do, the less automated testing we do. And so these companies, they kind of say you need to do automated testing. Automated testing is the cornerstone for continuous delivery. They say you can't do agile, you can't do continuous development unless you have suites and suites of automated testing. And really, I think that that is not the case at all, not in my experience anyway. I don't know if you know who this guy is. It's Henry Ford, who was one of the people responsible for productionizing the motor car. And he is attributed this quote, which was, he didn't actually say it, but they say he said it. If we'd asked the customers what they'd wanted, they'd have just said faster horses. And I really think that automated testing is the kind of software testing world's version of faster horses. It's taking the old process of manual testing, trying to bring it into the modern day by just making it faster. So, what I want to talk to you today, I'm going to try and answer some questions to try and convince you that I'm right and everybody else is wrong. And I'm going to answer these questions. How did you come to this conclusion? Can anyone try this approach? What are the benefits of this approach? What do the test team do if they don't do testing? We still have a team of 12 people at The Guardian who are working the test team. And how does change happen? So I'm going to answer those questions. So, the first question is, how did you come to this conclusion? Because it sounds pretty weird and radical. First of all, I'm going to take you back 6 years to when our software delivery looked a bit like that. So, what we had in the Guardian website, we had a 2-week release cycle. We had code freezes. We had go, no-go meetings. We had release managers. We had huge regression testing cycles. We had the whole thing. I mean, quite frankly, it was like something from the dark ages. And the reason that we had this whole kind of process of delivering our software only every 2 weeks is because we had key problems with our software delivery, okay? So we had 3 or 4 key problems. The first problem we had was that we couldn't release or deploy our software without any downtime. So this meant that we had to schedule our releases at 6 o'clock in the morning every 2 weeks, and we had to hope that there was no news happening, because if there was news happening, or say, for example, if there was a test match going on in the other side of the world, or if there was a kind of big news story, we'd have to cancel our release and schedule it for 2 weeks forward, because we couldn't release without any downtime. The second thing was that we couldn't roll back our software. And the third thing was that we had a really, really elaborate deploy process. We had an operations person who had to spend a good half a day scripting, doing manual scripting in order to deploy our software to production. So we, as well as those 3 things, we also had a massive, massive regression suite, which took, well, I say massive, massive, took 2 people, 2 full days to do regression testing before we could release. They used to test hundreds of URLs. We used to test all our editorial tools. So it was a kind of massive process in order to release our software. We looked at that process and we decided that it wasn't a great one to have and that we needed to fix it so that we could deploy more frequently. So we kind of got a whole bunch of people together in a room, and we said to the engineers that they needed to tackle the deploy issues. And over on the other side, the testers and the people in the QA team realized that we had to fix the long manual regression process. And that seemed at the time a really logical thing to do, because we thought if we don't automate our regression process, then the guys over here will have fixed all of the deploy things, the deploy problems, and we'll be able to deploy at will, but then we'll have this massive regression cycle. So we needed to fix that as well. So what happened was, the engineers went away and they fixed the deploying with no downtime, and then they fixed the ability or the lack of ability to be able to roll back, so we could then roll back our releases if we needed to. And then we created an in-house tool, this is a picture of it here, an in-house tool which meant that anybody in our digital department could deploy to any of our environments at will with a press of a button. So in terms of fixing our deploy problems, we were good to go. That was great. And then we were in a place where we could deploy several hundred times a day. Amazing. Over the other side of the room, when that had been happening, we had the test team or the QA team working away to automate our regression testing. So we'd hired a test automation engineer at great expense because they weren't very common 4 years ago. And we took our 2 best technical QAs out of their teams, and we sat the 3 of them in a room, and we said, automate all this regression. So they wrote tests, and they wrote more tests, and they wrote more tests, and in a year, they'd automated all of our regression. Amazing. Except it wasn't amazing, it was terrible. Everybody hated the tests. The tests were flaky, the tests took too long to run, the tests needed constant refactoring as the code base was changing. Everybody really, really hated the tests. And we were in this position where we could release our software whenever we wanted to, multiple times a day. And we suddenly realized, or at least I suddenly realized, and the people in the QA team suddenly realized, that we didn't need the automated tests. We just didn't need them. Because the reason we'd had this kind of massive regression cycle was because we needed to have everything perfect before we released it. You know, in the olden days, when we had our 2-week release cycle, everything needed to be perfect and bug-free before we released it. Because if we shipped a bug into production, we couldn't fix it. We'd have to wait for 2 weeks to fix it. And we'd just kind of done the same thing with our automated regression. But now we were deploying software multiple times a day. Didn't need to be perfect. Because if we found something, if we shipped a bug into production, we could just fix it. So we took this decision, kind of heartbreaking decision, to be honest, to scrap all of our automated tests and just do without them. We went for this philosophy that we like to call not wrong long. And we kind of have a similar philosophy in our newsroom, actually. You know, we would rather get a piece of news out to our readers and our viewers and kind of, I'm not saying we produce wrong news, by the way. I'd get lynched if anybody heard me saying that. You know, but we would rather ship something, either a piece of software or a piece of news, straight away and then add to it. So we kind of adopted this not wrong long philosophy, where we would ship to production and then we'd fix bugs afterwards if we needed to. And kind of previously we'd had this metric of kind of good quality, which had been the number of bugs in production, which we wanted to be really low. And after we adopted this philosophy, we changed and we said rather than the number of bugs in production, it would be how quick do we spot and fix things in production. And then another thing happened. We were at the point where we were shipping software multiple times a day. You could have a product manager scope out a feature in the morning. It could be worked on by a dev and ready to ship in the afternoon, just like that. Amazing. Except if you've got manual story testing in the mix as well. And right, so I'm from a QA background. I love QAs. One of the things I love about QAs and testers is they will test things to destruction. You give a tester a feature and they will test everything. They will test the happy paths, they will test the edge cases. They will not stop until they find all the bugs. And that is not compatible with releasing software multiple times a day. It's just not. So we then took a decision to kind of just not get hung up about testing at all, really. That we would take a kind of really light touch approach to testing. And we wouldn't really have a testing function at all, that we would distribute the testing amongst the whole team, and it would be done by the person who was really kind of most appropriate to do it. So we would have developers writing unit tests, we would have product owners doing acceptance testing, we would have designers kind of testing that things looked as they should, and you know, maybe somebody from the QA team might be involved in a bit of testing every now and again, but it certainly wasn't their job to do that. It was everybody in the team's responsibility to make sure that things were kind of okay before they shipped to production. So a light touch approach to testing. Sounds a bit mad. When I talk about this, people say to me, can anybody do this, really? Can anybody try this approach? Now, if you're creating the software for a self-driving car, or if in fact you work in critical systems, I think probably this is not the approach for you. If you're creating air traffic control systems and the like, if you're working in a safety critical environment, then probably you should test all the stuff before you release it. But I think really for anybody else, this approach is a good one. But you have to be able to mitigate the risk of this approach. And we have this kind of, what we like to call a toolbox of techniques that we use in order to kind of mitigate the risks. But first of all, I would say that you cannot use this approach unless you can deploy your software at will. So if you're doing continuous delivery or continuous deployment, or if you can basically, we're not doing exactly the textbook version of either of those at The Guardian, but we're doing a version where we can just deploy at will. So our toolbox of techniques that we use to mitigate this risk. The first thing is, and a really, really important one, is single feature releases. Okay, so there's a temptation always to kind of bundle up features and ship them, but that is problematic for us. We would much rather reduce the risk, ship features one at a time. That way, if there's a problem and there's a bug in production, you can trace it back to its root cause and fix it quickly. And so traceability becomes very important as well. The second thing is feature switches. We have feature switches or feature flags on all of our features across the Guardian products. So again, if we release a bug, we can turn it off. And in fact, it's just helpful for us to be able to turn off features at will anyway. Monitoring and alerting are extremely important if you use this approach. However, you have to be able to get the right amount of monitoring and alerting going. If you monitor everything, then there's too much noise and you won't notice the problems. If you monitor too little, then you won't catch them either. So monitoring and alerting are crucial, and the QA team are really involved in making sure that those things happen well. We do have some tests that run. I think I said 4 tests, and most of those tests run post-production. So we do have some systems where monitoring is not appropriate because we have low volume areas of our website, which we have so little traffic in that if you deploy to production, you wouldn't necessarily notice a problem for a while. So we have post-deploy hooks running so that tests run once a deploy has happened and they run in production. The next thing is operational metrics. We're really big fans of having production metrics running on dashboards and visible to everybody so that if we have third-party integration problems, that we can spot those straight away as well. And the last thing that we use a lot of is canary releases. So if you do have a very big and risky feature that you're trying to ship, that you use a canary release. So we moved from a .co.uk domain a couple of years ago over to .com. It was a massive and risky piece of work, but what we did was we shipped that first of all to our Australian users, and then when we were happy with that, we shipped it to our American users, and then when we were happy that it was completely risk-free, we then shipped it to the rest of the world. So this is a kind of toolbox of techniques that we use in order to allow us to kind of use this light touch approach to testing and ship to production. So, what were the benefits of using this approach to us? So the first one is kind of, I guess, a bit of a no-brainer. This not wrong long approach meant we could deliver more quickly, and that benefited both our users and our stakeholders. And, you know, the users always are happy with new features being released, and And our stakeholders were as well, actually. A lot of people say to me, how did you convince your stakeholders to use this approach? But they were happy as long as the quality didn't drop, and they were happy because they were having their features deployed into production more quickly than they would have been otherwise. So everybody was happy, really. The second and more interesting thing about this approach was that the teams cared more when they had more responsibility. So it used to be the case that, developers would just, product owners would, throw things to the developers, and the developers would throw it over the wall to the testers, who would then throw it into production, and, from there on, the operations guy. So we're in charge of it. Now, we don't really have that those areas of demarcation. Instead, everybody really shares the responsibility across all of our products. And we have what I like to call a safety net effect. So when you have a safety net in place of the testers and the test team, the tendency was to just chuck things away and hope that things were all right, but know that there was the testers were there to spot the problems. And when you take that safety net away, everybody behaves in a more diligent and responsible manner. So that was great. And the third thing is that the test team themselves starting added value in really unexpected and interesting ways, and started being happier and more creative about the way we approach quality. But what does that mean in reality? What do the test team do now that we're not testing? Well, first of all, it was really funny because in the olden days, we used to call ourselves the QA team, but all we ever did was testing. And we recognized that testing was just a subset of quality, that it wasn't everything there was to know about quality. So we started trying to think about how we could improve the quality of our products without doing testing. And what does that really mean? Well, the first thing we thought we needed to do, you can't see that very well, was we started creating dashboards that we shared with everybody in the team. So the thing is, if you say, okay, we want you guys all to do testing, everybody's doing testing now, you have to give people the tools to be able to make the right decisions about what they're testing. So we started making dashboards so that everybody could see what they needed to do. So this is which browsers are being used to access our website, which devices are being used, which operating systems are being used. And that was all things that the test team used to have and keep to themselves, but now we distribute them amongst everybody so that everybody can decide what needs to be testing and what doesn't. And then when you ask people to do a little bit of testing, you're going to need to make it a bit fun for them. So we created this Lego device wall, which houses all of the most common devices that are used to access our mobile website. We built it out of Lego so that we could reconfigure it. It meant that anybody who wanted to test a change that they'd made in production could enter the URL, and they could see that page on multiple devices. They could test things quickly and easily. But then this is when it started to get interesting. So those things are pretty obvious and testing related. But some things that we started doing were really nothing that could have been caught in a pre-production testing phase, if you like. So on the Guardian website, we have a type of article page called a live blog. And a live blog is a piece of content that is a stream of content which is updated by the minute. You could have it if there was a football match going on, or a large piece of news, and it can be hundreds and hundreds and hundreds of entries in one page. And we noticed sometime that some of these pages were getting too big in their page weight, and they were crashing some users' devices. But also we found that some users were complaining about their data plans being caned because they were just downloading too much data, irregardless of what speed they were. So we created a tool that polled our content API and worked out the page weight of all of these live blogs in production every hour, and reported on their page weight and the size or the amount it would cost a user to download this page if they were on a given data plan in America. And we alerted our editorial teams when any of those pages went over a given threshold. And then our editorial teams could go and kind of, these pages had lots of embeds in them, so tweets and videos and images. So we alerted our editorial team and they could kind of take action and remove some of the offending heavy embeds if we wanted them to. So kind of, this is something that would never have been caught with testing pre-production, but really something that's driven by the QA team in order to improve the quality of our product as a whole. The next thing we did is we started working on operational metrics. So this is a kind of graph of us monitoring the number of people who give us money at any given time, and we kind of start noticing when that drops off. So this was an iOS release, I think, that suddenly started or stopped giving us money. So we noticed that and found why that was happening. So lots of monitoring in production, but not of expected things. And we use our tracking to be able to kind of create these dashboards. And a really, really interesting thing that we started doing was we have an iOS and Android app and native apps. And when I said to you at the beginning, you can't do any of this stuff unless you have continuous delivery, or at least the ability to be able to deploy rapidly. That is not the case with Android and iOS or with native mobile apps. Because of Apple's review system, because users don't download updates to the software necessarily. It's always been a bit more problematic for us. But we decided that we wanted to use this approach anyway with our mobile apps. And so we created alpha and beta programs with both of them of several thousand users with the betas, and handfuls of internal users with our alphas. And so, and we still don't do really very much testing at all on our native apps. What we do is we use our alpha and our beta programs to let our users do our testing for us, and they're all very willing to do it. In fact, all of our beta users are recruited from within the apps themselves, so they're kind of very loyal users and are happy to help us. We use them to help find bugs, but also to comment on features before they go live to production. So it's kind of a dual purpose beta program. I think that was a really, really successful outcome of us changing the way we think about what we do. And then when we launched these alpha and beta programs, we were suddenly inundated with feedback from those thousands of users. And so we started trying to programmatically analyze the data that we get back from our users so that we can easily find out what they're commenting on. So those are just some examples of the things that the QA team do now that we're not testing. And it's been kind of quite a bumpy journey to get here. And I'd just like to talk very, very quickly about how change happens if you want it to. Because 4 years ago, when we said, let's stop testing, I can't deny it. I had a bit of a moment where I thought, that's it. I'm out of a job. I'm redundant now. And I don't know if you can see what this is. This is a job centre. I really thought that I was going to be out of a job, that there was no such thing as testing and QA anymore, and I'd have to find something else to do. But I really think you can and you have to adapt and evolve in this kind of industry where really things are changing all the time. And software and the way we deliver it and the nature of it is changing all the time. You can't afford to sit down and just think that what you were doing 2 years ago is appropriate to what you're doing now. I think if you want to change, you should. And if you're running a team of people who want to change, you have to try and find a couple of people who really buy into what you're doing and want to go on that journey with you. And you have to be aware that there's going to be some attrition, that some people aren't going to want to do that, and they're just going to carry on doing what they did before. And you're going to have to know that hiring people to do a new job that nobody understands and nobody has heard of is going to be really, really difficult thing to do. I mean, I've been through multiple iterations of job titles and job descriptions to try and hire people to come into my team. And you have to kind of be brave and know that you can just throw away a couple of years of work and that's going to be okay, and you can start again from scratch. In other words, you have to be able to adapt and evolve. So in conclusion, I want to make a plea to say, don't just ask for faster horses. Don't just settle for making a faster version of the previous thing. That's not going to work. You have to make a step change. You have to be restless, and you have to be bold. And when you've got there and you've thrown everything out and you've changed it all to something else, you have to know that probably you're going to have to do that whole thing all over again. Thank you.
Can you switch the mic, please? Thank you.
Lots of time for questions, apparently. Does anybody have any questions? I'm really deaf, by the way, so you might have to. I'm really deaf, by the way, so you might. No, honestly, so you might have to. I can't hear them.
Hi, we are from Critical Software, and I was just curious because you said that now you use only 4 automated tests, but you didn't enter in any detail of what are those automated 4 tests. So we were curious to know what exactly do you test?
Okay. So the most interesting one of those is, I think I was talking about the low bandwidth, or not the low bandwidth, the low usage area of our site, which happens sadly to be the commercial part of our site. So we have an area of our site where you can pay to become a member or buy a subscription to The Guardian, but we don't really, at the moment, have the volume of traffic in that area to be able to just ship things to production and hope it's fine. So we have a test that runs post-deploy, which basically goes through the critical path of purchasing a subscription, making a credit card payment, and making sure that a user is changed from a member to a supporter. So that's one of them. The second one of them is, I'm trying to remember what they are. Second one of them is we have a whole bunch of editorial tools which our journalists use to create the content, so a kind of an in-house bespoke CMS. It's really our only critical system in the whole of The Guardian, actually, because if we can't create content, then we might as well not have a website. So we just have a bit of a workflow automated test that runs, again, in production, which is kind of basically a WebDriver test, which creates a piece of logs into our system, creates a bit of content, publishes it, and then takes it down. So we have to, which is actually the most critical path of all, because we can publish content, fine, but if we can't remove content from our website, if we have some legal requirement to do so, then we're a bit stuffed. So that's another kind of critical path. So we do that. That runs every minute, which is interesting because all of our users of our CMS are in the building. But what we wanted to do was make sure that we were alerted by our automated test before any journalist came running up the stairs to tell us it was broken. So that was the second one. Our third automated test is actually in our apps, which is we created this kind of massive beta program, which was amazing, and gives us loads and loads of feedback. But the one thing that we realised after quite a while of running it, and this was, you know, not great to admit, but we realised that the one thing that our beta program didn't test was our onboarding of new users to our apps, because they were all by definition existing users of the apps. And so we have a test which goes through the onboarding process of our apps. Can't remember on this stage what the fourth one was, but that kind of gives you an idea of the range of tests that we do run.
Yes, thank you.
Hi, Sally. So thank you for sharing your approach. I'm Bruno from Farfetch. I'm an agile coach. So my question is, from the dark ages, Q&A and excellence in a Q&A person is seen as the person who stops bugs going live. Okay. So how do you see in this approach excellency in a Q&A?
How do I see what? Sorry.
How do you describe an excellent Q&A in this new approach?
I think it's somebody who has to be somebody who has to care first and foremost, more than anybody else, about the quality of the app in all its guises. And it's interesting because we did do an experiment where we first tried this approach with some people from the QA team who we just said, well, let's just make them engineers, because we had some SETs, and we said, well, let's just move our SETs, software engineers and test, into the engineering team. Generally, they'll report to an engineering manager, and they'll be kind of like an ambassador for quality, but they'll be doing engineering stuff. They'll be working on stories. They'll be doing that, and you'd be amazed at how quickly those people were just assimilated into being engineers and just really caring about building products, because they were reporting to the engineering manager. Although they kind of cared a bit about quality, it wasn't the thing that was the foremost in their mind. So we still have SETIs, so we call them software engineers in tools and infrastructure along the Google lines in our QA team. But their brief is to care about the quality of the product, right? And that's all that is what their brief is. So they kind of come in and they start a job with me and they say, what shall I do? And I say, improve the quality of the product. There you go away and do it. It's up to you how you might do that. They have a kind of very open brief, but you know, every week I talk to them about what they've done to improve the quality of the product and how they measure it and how they do it. So it could be that tool that we've created, which is, you know, make sure that our live blogs are not, you know, have a kind of light page weight rather than anything else. It could be our internal tools. It could be finding out, doing an audit of what people like and don't like about the tools that they use. So it could be setting up the beta programs, answering user feedback, making dashboards, improving monitoring and logging, as long as that thing is to ultimately improve the quality of the app in some way, or the product in some way. Does that answer your question?
I do believe so. Thank you.
Okay.
Hello, Sally.
Hello.
First of all, my name is Sarah. I'm from Farfetch. I'm an agile coach. First of all, I'd like to congratulate you for your presentation. It was great. You talk about product owners, 2-week releases. So I think you work with Scrum, I suppose. I would like to know, how do you make those decisions of changing the releases, the process, the work of your team? How does that work? How do you work with your team? Is that a team decision, brainstorming? How do you
How does it
process that? How does that happen?
I'd love to say that it was extremely well thought out and we had lots of meetings and everybody agreed, but you know, that's never the way it works, is it, right? In software development, I don't think. Firstly, I should say we have lots of different products and lots of different product teams, and they all work in different ways because they all have different requirements. So, you know, our apps team and our website team and our payment system team and our content API team all have completely different structures, and some of them work with Kanban, and some of them work with Scrum, and some people have never seen any kind of Scrum type ceremony for months and months and months. So they kind of all work completely different, and the teams at The Guardian are given very much autonomy to work in the way that they want to. But I guess kind of these changes happened, as I say, kind of 4 years ago when we moved over to kind of more kind of rapid software delivery. We have a kind of DevOpsy model. So we used to have a massive operations web sys team. We scaled that right down, and then we integrated some of the engineers that were left from that team into our product team. So we don't have operations. So we kind of moved to a kind of DevOps way of working. And I kind of think that like other parts of the product team are kind of too far behind in kind of working in the same way, right? So I think QA, generally speaking, is still, you know, has a very kind of old-fashioned attitude about working and should be more incorporated. You know, we kind of talk about sec DevOps as well now, but also I think, you know, for me, right, UX, I don't know if there are many UXers in the room, UX is way behind as well, you know. I think that whole barrier, that kind of whole, what's the word? It's gone out of my head. The barrier of having kind of to go through QA bottleneck. The whole bottleneck of QA, there's a massive bottleneck of UX now as well, isn't there? And you know, for us, when we want to kind of deliver every day, several times a day, having somebody in QA who says, oh, you can't release that yet, I've got to test it. We've got rid of that, but now on the other side, at the kind of start of the process, you've got some UX guy or woman saying, oh no, you can't release that yet, you know, we just need to do a few more tests, we need to create few more wireframes, you know, and those become the kind of impediment to releasing quickly. So we're kind of not moving fast enough to incorporate those things. I'm not answering your question, but it's
you put them all together and talk together.
Do we? No, I think because, I mean, we have with QA, but I think this is why I want to give this talk and say be bold, right? Because I think you can become very conservative and you just think, people are saying, we don't need QA, we can test it in production. People get really nervous and say, well, I don't want to do that, you know, because that's my job and what am I going to do? And I think I see the same thing with UX, you know, they're really, really holding on to their kind of that role that they do. This is probably controversial, they're probably holding on to that role that they do, where I would say ship things to production, test them in production, find the bugs in production, do your A/B testing in production. You know, you can release quickly and you can analyze the data quickly. Why not just get it out there and then find out if it's the right thing, find out if it's broken? You know, and I think the people who are in those teams are resistant to change because it's scary. So you have to have, I guess, you know, I've driven this change along for my team. You know, I would love it if somebody in the UX team had the same drive to change it that way. But, you know, I don't see that happening yet. But I think it can happen.
But the decision was a team decision, or it came from some above?
It came from me and from some of the senior software architects in the team. It doesn't, you know, it's not easy, right? It's not fast. You have to find some, this is what I was saying at the end, and maybe it was a bit throwaway, but you have to find some people in your team who just go, oh yes, yeah, I know what you mean. I can do that. And some people in my team did leave, 3 or 4 people. They're like, no, I just want to be a test automation engineer. I want to work with WebDriver. I want to write hundreds of tests. I'm happy doing that. And they, and they left to go and work in other companies. But, a lot of people, the people who stayed and the people who used to do testing are much happier now than they were before. And they're treated in a kind of a much different way, because they're not the bottleneck to stopping things from going live. They're the person who adds value in different ways, whether it's at the front or at the end of the process. So, you have to be able to kind of convince people.
Okay, thank you.
Hi, Sally. Good morning.
Hello.
Hello. My name is Manuel.
Hi.
And first of all, thank you very much for your insight. It's very interesting because it crosses actually a recent experience of mine that I would like to. So I have some questions that come from that experience. First of all, I hope you're liking the city. And welcome. And I would like to tell you that I'm one of your users, because I have the iOS app installed on my iPad and my mobile phone, and so I follow The Guardian every day, and I republish on my Facebook page and stuff. So I'm
Great.
One of your users. It works well.
Could be good or bad here, couldn't it?
It works well, actually.
Right.
So, but from my recent experience, I had one recent experience on one big pharmaceutical company. I must tell you that I am an SAP consultant, and I work with SAP software for 19 years now. And I had a recent project on a big pharmaceutical company, which actually is the biggest one and one of the biggest companies in the world. I heard that there are two companies in the world that are rated AAA, which is Apple and that company, which is Johnson & Johnson. So I had an experience in Ireland about their first experience of building excellence center, running Scrum and Agile for SAP implementation and delivery. They had some experience on web content as well before in the US, but the first team set up to deliver using Agile was on a new center there. And I participated from a developer and a consultant perspective. And they were building automated tests, developing using Python. Okay, so I am a testimony. I participated. I assisted. I saw the clash of cultures that needed to be aligned for everything to can work, because that company was delivering SAP implementations on a big.
Sorry, I think we've run out of time. But why don't we talk in the break? Sorry.
Thank you.
Thanks very much, everybody.
Okay. Well, I know you may have more questions for Sally. You can find her probably during the coffee breaks. We will have another session here at 12, and there will be another on the other room. So if you want to change, you have like 5 minutes now, and see you here at 12.
Okay. I need to be here. Okay, cool. Can you do this if my volume is good, or you do that if it's too low, right? Can you hear me? Louder? Like this? Cool.
Let's do this.
Okay, 2 minutes.
Yep.
Hi everyone, welcome again. So now we're going to have Christopher Noring, which is a Google developer MVP stuff. I hope I'm not wrong. But he's an expert in web technologies and Angular, and he's going to talk to you today about NativeScript, which is an amazing framework, cross-platform framework to develop native apps. So welcome, Christopher.
Hi, everybody. Hope you can hear me. Chris Noring, as he said, Google developer expert. I work in London for an energy company called OVO Energy, where I do a lot of front-end development. Cool, let's see where we're at. You can see that. Cool. I'm going to focus on the Angular 2 part of NativeScript, because NativeScript can be had in two versions. Either you code pure JavaScript to it, or you use Angular 2. And me being a GD in Angular, of course I'm going to promote Angular, right? A little bit about me. If you're interested to communicate with me, here's my Twitter handle. So, first of all, before we start talking about NativeScript, let's talk about what's out there for building apps. Of course, we got native. And when it comes to native, we got Android, we got the iOS platform, we got the Windows platform. And, that was a bad shade. Okay, so basically here I'm saying we have access to things in native like camera, GPS, push notifications. We also have an app store and a marketplace, so we have a plan for actually making money off of our apps. But we usually need one dev team per platform, and as everyone knows, that's going to cost us a lot of money, because that means we will have a team of Android developers, a team of iOS developers, possibly a team of Windows developers, and so on. So for that reason, maybe in some cases we're not going all native, we're going with other kinds of solutions, because we want to save money at the end of the day, at least if we are a CTO. So for that reason, we have web apps. They are great for very simple scenarios. I'm going to read you the text, it's pretty weak here, but what I wanted to say about web apps is that they're great if your scenarios are simple and the only thing you want to do is to take in a home page, make it into a responsive one so it fits on a small mobile screen. And by that, it's going to cost us less, because we have one team that's going to be using JavaScript and CSS. But we do have very limited access to hardware, so if we have that kind of features that we want to add to the application, maybe web apps is not the best fit for us. For example, we have geoposition, but we don't have a camera and those kind of things. And another thing is actually going to increase the cost for us, which is the browser support. And because of the fact that we need to maintain the code base for Safari, for Chrome, for all of the different browser vendors, they will implement stuff in very different ways. And of course, they're going to change the browser. They're going to upgrade it, which means we have maintenance costs happening down the line. And stuff will break. And of course, with a web app, we don't have the opportunity to monetize in a good way. We need to figure out how do we actually charge the users if we want to charge them. How do we make money on the web? And of course, when you develop a code base for Android and iOS, we have the problem it doesn't feel quite Android, it doesn't feel quite iOS. Web is a compromise, from a UX standpoint. For that reason, we have something called hybrid frameworks. So a hybrid is really just an app written in CSS, HTML that is being launched in a web view, which is a component. And candidates here that we could choose from is Titanium, React Native, Ionic, and so on. And we have the problem that we need to learn the specific API for that framework, which could be a problem. Okay, sure, we have a simplified view here. We got JavaScript only, but there's still an API to be learned. It is possible to use an app store. We got limited access to hardware, but the support is getting better and better. If you see the Cordova matrix, it's actually supporting a lot of hardware features. And of course, a lot of really cool features are being added to the hybrid frameworks like WebRTC, WebGL, WebAudio, IndexedDB, and so on. So we're in a pretty good place with hybrid frameworks, and that's usually a very good match for us. But we are rendering in web views, so we're still not truly on the native platform. And we got a new kid on the block called Progressive Web Apps, which is more of an idea than an actual framework that we can use. But once implemented, it should be cacheable, it should feel like an app, it should have progressive enhancement, which basically means that we have better features, the better browser we have, and the better broadband we have. And we also should have push notifications, but we still have the problem of how to monetize. And Safari hasn't really implemented anything yet that's worth talking about when it comes to progressive web apps. So I don't even think Apple has it on their backlog to implement this. But once they do that, and once all the great vendors are in on this, it could be the future. Until then, we have NativeScript. So how does NativeScript fit in? You hear me well, right? Awesome. So it's not web with NativeScript. You are writing it in JavaScript, but you don't have a DOM. You don't have any tree to code against, because you target the actual APIs on the native, right? Sounds like voodoo, right? So it supports hardware by it actually being native, although we are using JavaScript. So we can use our JavaScript and CSS skills, and you can use your native developers because they actually know the API. And this is a very important distinction if you compare it to hybrid frameworks where you actually have to go with JavaScript people. In this case, Android developers and iOS people are actually very important for you because they will shorten your development time by them knowing the API. They know how to do stuff. They know what the methods are called. They know what the modules are called. So here we have a framework that actually allows you to use native people and web developers in the same team because they actually complement each other. So it's not either JavaScript or native, it's both. So what are the killer features for NativeScript? As I said, you can style your UI with CSS, which is very comfortable. You can use JavaScript or Angular 2 with TypeScript, which is nice. Show of hands, how many have used Angular 2 so far? A few hands. Cool. Then you should be very familiar with this environment, because if you know Angular 2, you're already far ahead. You can almost code an app in NativeScript as it is. And of course, it's going to be fast, right? Because if this is going to run on the actual device, it's going to use the GPU, and it's going to go very, very fast to have animations run. And you can monetize this because you can use the App Store and you can use the market. So you really don't have to worry about the money issue, which can be a big issue. And one really important feature with NativeScript is its pluggability. It's very easy to write new plugins. If there is functionality that you need that's not there from the NativeScript team, you can easily build your own plugins that's going to expose a native API, and you can actually upload that to an app store so a lot of other people can use it. And best of all, it's free. Telerik components usually cost money, but in this case, it doesn't. So how does this black magic work? I mean, it really seems like magic, right? We are using JavaScript, but it's still able to target the native API. How is this possible? Well, the NativeScript uses a JavaScript virtual machine when it executes the code. And which virtual machine it's actually using depends on where you are. So if you're on Android, it's going to be using the V8 engine. And if you're on iOS, it's going to use something called a JavaScript core. And take this line of code here, for example. We have a line of code that very much looks like JavaScript, but it kind of also looks like possibly Java. But this is JavaScript. It's being JIT compiled, it's being executed by the V8 if you are on the Android platform. But how does V8 know what Android text format time really mean? Well, the first explanation to this is the fact that on the V8 engine, and if you use the other virtual machine, there are APIs that lets us actually interact with the engine itself. These APIs will let us affect the global scope. So what we do from NativeScript is that we inject APIs into this engine, so it suddenly knows about Android or it knows about iOS. And as I said, the JavaScript core has a similar functionality as the V8, so we're able to use the same approach from a high level. So NativeScript injects either an Android or an iOS object that contains metadata that basically is a documentation of our API, which methods are available, which objects, and so on. But here's another really interesting question. Okay, so it's able to inject metadata, so it actually recognizes what we're trying to do, but how does it know what to inject? How does it know to inject the Android or the iOS things? And most important of all, how does it know how to interpret that line of code into something that actually executes against the native APIs? The first answer is that NativeScript uses reflection to investigate its runtime, and once it discovers, like, aha, I am an Android, so I should actually inject Android metadata. Or it will say, I'm on iOS, and inject those metadata. So, and here you have the other answer, which is how does it know how to interpret this into something native call? So what's really happening here is that it's associating this line of code with a callback, and once this code is being executed, there is a callback that actually intercepts when this is being run and says, okay, let me take this, let me transpile this into a native call in C++. So every single line of JavaScript code is being associated to a callback with C++. And on the Android, we're using something called a JNI bridge that basically translates our C++ into Java. And for iOS, we can directly talk to our native API. So you see here, we have a translation process happening. So in conclusion, NativeScript investigates its runtime environment and injects the metadata needed for the compiler to understand what code can I actually use. And the other part is there is a callback associated to each line of executed JavaScript and C++ is being run in its place. And on the Android platform, we have the JNI bridge that translates the C++ to Java, and on the iOS platform, it just talks to the native APIs directly. Are you with me so far? Great. So there. we have the whole technical explanation of how NativeScript actually is able to take JavaScript and have it run on the native. So NativeScript itself, it is a JavaScriptified version of either the Android platform or the iOS platform, but to conceal this in a good way to us users, it's actually encapsulating two different implementations depending on the number of platforms. So let's say we have two different platforms. That means we're going to write a module for Android and we're going to write a module for iOS. And in runtime, it's going to decide which one to use. So from our standpoint, we are coding TypeScript. So we don't really have to care about the choosing. NativeScript engine is going to do that for us. The only thing we need to know is that there is a module, the module has this and this method, and it's going to perform this for us. So imagine that you look inside of a NativeScript library, then you have the node modules. The node modules catalog will list, under TNS core modules, it will list several different modules, and for example, it will list a module called camera. So if we break apart camera, we will see that it consists of an Android version, an iOS version, and usually a common version. So in here, we have the JavaScriptified calls to Android. We have the iOS version of it. All of these implementations are JavaScript, but it's kind of using the JavaScriptified version of either Java or Objective-C. And for us to use it in TypeScript, we only have to require and we're done, because the selection here, either this one or that one, is being handled by the NativeScript engine and we don't have to care. So how easy is it to get started? The first thing you need to do is to run the npm and install the NativeScript, and depending on what environment you are on Windows, you need to execute the PowerShell command, and on the Mac, you need to execute a Ruby command. I'm not asking you to remember this, just to give you an understanding of how easy is it. So basically, it's a two-step installation process, and you can verify your installation by running TNS Doctor, which, if everything goes well, will give you a long checklist of saying, yes, 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 awesome, everything works, you are ready to code in NativeScript. But if you're on the Android environment, you might have to do a little bit more extra step, because the emulator on Android is a bit slow. So Genymotion is a company that released an emulator for Android, which is very, very nice to use and very, very fast. So if you code for Android, download this thing, and the only thing you need to remember is to set the Android SDK path, and you're in business. And for the iOS, you can use the emulator that's there because it's fast enough. So first app. You can either choose to take one of NativeScript's sample apps, then you do just a git clone of this one. This is written in Angular 2, so it will showcase how to do a lot of different stuff, like animations or working with lists or working with HTTP and so on. Or we could be using the scaffolder and actually do TNS create with the flag here called ng, if we are targeting Angular 2. If we're not targeting Angular 2, then we don't need that flag. But as I said, I'm talking about NativeScript with Angular 2. So scaffolding is going to save you a lot of time. So what is the dev experience like? I mean, for us to really, as developers, to use a framework, we really need to make sure that the tooling is good, right? If you've got shitty tooling, we're not going to use it. It needs to go fast. We need to have a good support. We got demands, people, right? So for Visual Studio Code, we have a plugin that's going to enhance our developer environment a lot. So we're able to set breakpoints when we debug. We can also be using hot reload, so code is recompiled and redeployed every time we do a change. And when I say deployed, I mean deployed to an emulator. And of course, in today's world, we need to be able to run and create unit tests, right? I mean, we're not going to be able to get away with writing code that may work. We need to prove it. So for the hot reload, is as simple as running the live sync command here with the watch flag, and it will rebuild and redeploy when you change stuff. So compilation, deployment, you hit save, and it's going to redeploy. For the debug, It's pretty simple, just run TNS debug, and if you use the Visual Studio Code, you're able to attach to this process, so you can decode inside the VS Code. Did I say decode? I mean debug. And depending on what state you're in, let's say that the emulator is already running, then you run the start command. Let's see here. This one, instead of just running this one, which is default. So it's worth investigating once you're up and running what kind of different options there are. So let's say that we start to debug. What then? So it's going to build our application. It's going to start the node inspector if we're not using VS Code alternative. And it's going to launch itself in the Chrome browser. So this is going to look like that. So to the left here, we have our running applications. And to the right, we have the node inspector running. And we can set breakpoints whenever we want, which is very nice. And there's another alternative for Eclipse with a Chromium debugger if you want to go that way and you really like Eclipse. And as I said, there is a plugin for Visual Studio Code. And the only thing you need to do inside of the VS Code environment is to run this command, and it will install it for you. And it looks like this. Here you can see on the left that depending on whether our emulator is up and running or not, we can actually launch it from the get-go with nothing up and running. It will start every emulator for us. Or let's say something is already running, then we just attach to it. Pretty simple, pretty standard. So, okay, this sounds nice, right? We got decent tooling, what it seems like, but how hard is it to accomplish something? Can I use my Angular 2 skill set? So we code in Angular 2. And we got UI components, we got layouts, we got HTTP support, we got CSS animations, we got gestures, hardware, and more. And as I said before, we can easily extend NativeScript with plugins. And we can write our own plugins, which is going to save us a lot of time next time we write a NativeScript library. And if we're nice enough, we can upload that to a market store. So we can be productive with all these components. Let's just have a look at what it actually might look like in the HTML part of things. So here we have a label at the top here, and we're having a normal one-way binding as we're used to in Angular 2. With the button component here, we got an event binding, which also looks like we're used to. If we are used to Angular 2, that is. It's a pretty new thing. Here we got the ng model, which has the banana in the box binding, as it's called, which leverages two-way binding for us. So, given that you know Angular 2, you just have to learn what are the UI components called, because the binding knowledge you have, the Angular 2 knowledge you have, you can use that. So you're already up and running. So, file system. What can we do with files? Well, we can do what we're expect to be doing with files. We can do a create, read, update, delete on files and folders. Oh, file demo. Let's see if this works well. There you go. Don't see. I need to switch this one to, can I have it launched this way instead of that one? So this is probably a separate desktop. I think this is a separate desktop altogether.
Wait. And it's in this one. To the presentation. Go to display. Settings.
Sorry guys, we just want to make sure that we can show you the demo. I think maybe it's extended or something. Arrangement maybe? Can it, Oh, great, we're back in business. Can you take the white one there? Yeah, this one. Yeah. Just click. I think. Wait. You can see that, right? Cool. Sorry for the delay. Okay, so here I have a list of demos that I'm gonna show to you in order. We talked about the file demo. Thank you for your patience, by the way. What I wanted to show you with the file demo is how easy it is to actually load the contents of a file. This contrast is not good, but I can tell you what you're looking at. So we're looking at the fact that we have opened the file, and it's easy for us to just edit the content of the file and save it anew. You just have to take my word for it, basically. But it's very easy, and all of these demos that I'm showcasing to you, I'm gonna upload them to a GitHub so you can try for yourself. Let's go back to the presentation here. See that? Good. Next topic, layout. And this one. So, of course, we got some kind of layout concept, right? This is going to make it easier for us. We're not going to be using CSS or some weird grid. We are going to be using absolute layouts, doc layouts, grid layouts, and so on. These are the kind of layouts that we're used to when we code something for the desktop, right? As you can see, we can either place stuff exactly with X and Y. We have the doc layout, which basically arranges children components to the outer edges, and the very last component will take up the remaining space. And if you have a layout that's grid-based, then we can define it in columns and rows. And probably the most common one that you're going to start with is the stack layout, which enables you to lay out the components either vertically or horizontally. And of course, we got the wrap layout, which basically lays out the components like this, one after the other, until there's no space, and then it just changes row. So, navigation. The thing I'm going to say about navigation is basically, it's the same as Angular 2 router. So, if we know how the router works in Angular 2, we are in business. CSS. So, what can I do with CSS? Is it possible to do all that weird things that our designer on the team is going to want? You know, usually when you work at a big company, right, you got UX people, you got designer people, you got programmers. The problem with that is that designers tend to go overboard with the design, and maybe it's going to take you a long while to implement everything. So the basic question here is, can I do what the designer wants? And my honest answer to this one is almost. For example, they don't support box shadows currently, but they're about to. You can actually do some weird hack if you want box shadows already, because it's, well, there are native calls that you can do. So for the CSS, we can either affect it on a global level, app CSS, or we can specify like we're used to in Angular 2 with the style URL or the style tag. Or we can use inline CSS on the component like so, with the style property, or here's a variant that's not really CSS, but we're specifying a property straight away on the component saying this is the background that we want. If you want to read more about styling and what's possible currently to deduce whether should we use NativeScript or Ionic or something else, this is a very good page to get updated. Plugins. So plugins is really what's making NativeScript very good, because we're able to build upon a core that actually leverages a lot of interesting functionality as it is, but we can build upon it. So, what is a NativeScript plugin? Well, it's basically what I told you before about the module, but it's just another name for it. So, a plugin is an NPM package that exposes a native API, which, as I said before with modules, means that we have an Android version, we have an iOS version, and we got a package JSON, and possibly a common file that works for both. So the thing you need to do, the steps you need to take to create your own plugin is to look up in iOS and Java respectively and see how are these guys doing it, you know, in iOS and Java to accomplish something. So for example, here is a very, very small example, just to give you an idea. Here we can see that we have an iOS Objective-C call. We have the nsDate calling a static method date to get a date. And here we have the corresponding Android version. And you can see here, we can use our JavaScriptified version to call this, which means here, this is what the JavaScript version of the same code looks like. So as you can see, it's very, very similar, right? So it's very simple for us to say that, okay, nsDate, the only thing I need to remember is the casing here and the fact that I'm using a dot notation instead of using this way of invoking a method. So that's why I'm saying your native developers are your best asset here, because they know the API, they know the classes, and they know the methods. So use them. And for the Android, you see that it's almost the same. Very, very similar call because, well, both of them are using dot notation. And the only big difference here is the fact that we need to qualify the full namespace. That's pretty much the only difference between the JavaScript and the Java version. But as you see, there was a bit more difference between these two, but the difference is not that big. And when you're done, we can add these implementations here that we do. This one we're going to add to this, and these implementations we're going to add to the Android version. So although this is a very simple plugin, hopefully that means that you will understand how would I create a plugin. So to add the plugin is just a matter of calling the right command, and as you see, it's a one-liner to remove said plugin. And as I mentioned before, Telerik has a verified marketplace where they actually investigate every single uploaded plugin to see it actually works and can be used by you as developers. So really look at this marketplace before you try to build your own stuff. Sorry, wrong button. And there are a few articles here that I included. All the slides will be made available for you. And these are very, very good to get started off the ground with your first plugin. Are you guys still awake? Good, good. Not boring you too much. Okay, so what I was trying to sell here to you, if I'm selling, you be the judge of that, is the fact that we can talk to hardware, because this is actual native. And of course, to talk to a camera could be a cumbersome task to do on iOS or the Android, but they have made it even simpler. So in this case, what we need to do is to import a reference, and it's basically just one method call that's take picture with a few properties here. We just decide the width and the height, because the default width and height is crazy, right? So we need to override this one, or we're going to have a very, very large picture, and, well, you're not going to have that much memory on your device before soon. So this is a promise, which means that when it's done, there is a then callback that you can do whatever you want with. And in this case, you see I'm assigning it to a source property. And once that's done, here's the UI layer where I actually just assign it like this. So this is very little code just to take a picture and display it in an image control. So very easy, right? So import a reference, take the picture, and display the image. 3 steps. And I have a camera demo, and this will go faster this time, hopefully. So the first thing we need to do if we are on an emulator is to actually turn on the camera. So me being an iOS user, I need to learn how to do this, well, the first time at least. Let's see. Camera on. Let's do a preview. Ah, it actually seems like it's seeing me, which is a good sign. So all good. We go back because we do the camera demo. Camera, take a picture. Normally when native scripted guys do this on stage, they tend to take the whole computer or device that they're having to do a selfie with the crowd, but I fear I'm going to tear everything down, so I'm not going to do that. So this is a bit crooked, but when it takes the image, it's going to look all right. So here you can see it's taking an image. It's asking me, are you happy with this image? Yes, I am. Let's take it, and presto, it's being displayed inside of an image component. So You see how simple that was. There was only those method calls of taking the image and display it in the image component. Let's see where we are. Camera demo. There. Cool. How are we on time? Still good? Cool. So, images. I just wanted to say what capabilities there are on this platform. I'm going to go back to my corner and not be in the way. So, images can be displayed in different ways. Here is the first way, which is URL-based. So we take some URL of the internet and we display the image inside of the image component. And the other way is to refer to our file system within our project. And then we start with the tilde/images, and that means basically it's going to look from the app folder and down. The third version is to be had as a resource with the res :/ keyword, which means instead of looking inside of the app folder, it's going to look inside of something called app_resources, and either inside of Android or iOS. So it doesn't really matter if this link is exact at this point. The important thing here is that it's inside of this, so if it's 3 or 4 levels deep, it's still going to find it. It's very clever. So, geoposition. Sadly, I can't demo this because I'm on an emulator, otherwise I would have been able to. But geoposition is very simple, so let me just show you the code for it. The steps that you need to take to make geolocation possible and take your coordinate and display it on the map is very simple. So first you install the plugin. The first step that we need to do after that, code-wise, is to check, is it enabled? So if it's not enabled, we need to ask for permission. So first we have a reference to our installed plugin. Let's assume that we actually did this step. And after that, we are going to check for geolocation. If it's not enabled, we are going to launch a request, which basically will take us to settings window saying, do you want this app to be able to track your location? So much for enabling, but how do we actually use it? So let's assume we did these steps. We have been allowed to use your X and Y coordinate. Then we ask for location. And that is as simple as taking the reference and get the current location. And we need to specify some parameters about how exact the position should be. Once we have that, we have a location with an X and Y that we could output on a map. And for example, we could be downloading this plugin to just take our location and display it here. So you see there are very few steps here to make this possible. But as I said, use an actual device when you try to test this one. Otherwise, you will have to use like Telnet and send some spoofed XY coordinates. So it is possible to make it work with an emulator, but I really recommend to use an actual device for testing purposes. Animation. So what cool stuff can we do with animation? We can rotate, we can scale, we can change opacity, pretty much anything that you can expect to do currently on an Android or iOS. And as before, it's a very simple thing. We just take our UI component, we call an animate method, and we specify a lot of properties that we want to happen when the animation is running. For example, change position with translate, we can scale, we can rotate, a bunch of stuff, as you can see. And as with all the cases when stuff takes time, it's a promise, so once we're done, we can just do whatever. So it is pretty simple, right? And of course, I got the demo for that. But bear with me, my computer is not the fastest one, so this is a lot faster on our device. You can see that, awesome. Okay, so here we have a case where we try to animate by translating, and we're trying to have a nice animation effect. So here we can see that we can suddenly have stuff animate away from us. Imagine this being a fun game of some sorts. So as you can see, we're very easy up and running even with animations. But animation is an art alto itself. I mean, it's very easy for us to add too much animation and suddenly we have an app that no one wants to use, like, Ling's cars that a colleague was telling me about. Where are we with time? 37. Ah, pretty good. So, if you fell asleep today, just remember this slide. NativeScript is a platform that enables you to use the actual APIs with JavaScript. Thank you for listening. I think we have some time for Q&A. Anyone has any immediate questions? You're all hungry, right?
Can we switch them? Can we switch? Thank you.
I'm going to be available for questioning even after. There's a question.
Hi, Christopher.
Hi.
Thanks for your presentation. How do NativeScript deals with platform-specific modules?
So the way it deals with platform-specific modules is the fact that it will, in runtime, choose the correct module. So because we have one Android implementation and one iOS implementation, it will just say, this is the one I need. Exactly. So to enable that we support it in the best possible way, we as plugin developers, we should ensure that we support iOS or Android. It's usually best practice to do it that way.
So it's developers' responsibility to develop for both?
I would say so, but I mean, let's say that your company only develops Android apps, and you have no interest in outputting it for the Telerik platform, for example. You don't want it to be global available plugin. It's only for you and your company. Then you're fine just building one file. But you know, if you one day decide to do iOS, then you need to go back and change every single plugin and add an implementation for the iOS.
Thank you.
Yeah, hi here, iOS developer, by the way. Does it support over-the-air installs? Like, can you update an app solely deploying it to I don't know, to a server or something? Do you have to go through the whole process of the App Store or Play Store?
I'm not actually sure on this one. The deployment I've seen for NativeScript has been the usual App Store way.
Process, yeah.
I'm actually going to ask the guys at Telerik for the answer here. I'm not sure.
Okay. Just one more. How is it the performance against a native app?
Yeah.
If you build both apps equal?
I would say it's a one-on-one comparison.
With animations?
Yeah, exactly. So
Okay.
the point I was trying to make here is that every single piece of code line that you're using turns into native code.
Yeah, does it archive, when you archive the app, does it make like whole Objective-C app, or can you see it, or it just the build?
Yeah, so what it's actually making in the project tree is that it creates a platform-specific directory where it actually creates the Objective-C code that's needed. So it's actually emitting on a binary level for the iOS and for the Android. So the end result, you couldn't really tell whether it came from NativeScript or if you wrote it in Objective-C.
Okay.
So on a binary level, they are exactly the same.
Yeah, great, thanks.
I think we have someone over there in the bottom right.
Hi there.
Hi.
Great speech, by the way. I was going to ask you, do you think these kind of frameworks will slowly and along the way be replacing native apps as we know it?
You're asking me to make a guess here, but I would say that most of the world is turning into JavaScript right now, and because front-end is very trendy, which means that trends come and go. So there's no guarantee that NativeScript is the one thing that's going to survive in the future, and Swift coders or Android coders are not going to be around. I would say that if I were to make an educated guess, I think this framework is probably going to be around for a while. I know that Google is very interested in supporting this because they are targeting Angular 2 as one of the dialects to be used. Usually that means when you have a big company around it, there will be a great ecosystem. There already is a great ecosystem behind it with Telerik. I definitely think it's going to be a good contender to the, only native. So, and of course, I think it's going to come down to how much money you have. If you have the money to support an Android team and an iOS team, maybe you're not looking into native script at all. But if you don't have the money, this is probably the best option out there.
Okay, just a little question. How do you cope with all the SDK segmentations on the various platforms, Android and iOS? When iOS 9 came up, the old assets library functionality were replaced with the photos library functionalities. How do you cope with that?
Yeah, so because you actually have to install the SDKs for Android and for iOS to making this work, every time they release something means that they will try to update native script as fast as possible, which means the native script modules will be rewritten to cater for that as well. Of course, they can't be, truly updated like the week after, but maybe a few months after they will actually be in business. So the native script team is working really, really hard to make sure that the modules are being rewritten to cater to the latest version of the iOS and the Android. Any more questions? There's one. Last question.
Hi, Chris.
Hi.
I actually had 2 questions. I hope you can make it. So first thing, how much code do you share between what you use for the native apps and web apps in real life?
I think that's a very valid question, because if you were to write a shared library in a web app, you'd probably not be using it for anything more than that project. That is the reality we live in. So it's a very good point you're making. I think if you make a very general purpose thing, such as a flashlight or some kind of gyro or some kind of cool camera support that actually feels like this is a common component, then I think you're going to share it. But I think in most cases, when you write like a business layer thing or something like that, then probably what you're working on will change over time, so you're likely to rewrite it anyway. So I would say that any plugin that you write that's intended for hardware or something very general purpose will be used in your next project.
It's not exactly that. What I meant is that between web implementation, something you use in the browser, in Safari and Chrome, and something you use in the apps, the native apps.
Okay, so you're saying that you have a web team that's writing a web app, they make a cool library, and they want to maybe use that with native script?
Yes.
You have all the possibilities in the world, really. I mean, if you're, for example, on an Angular 2 project and you write some cool lib, then it's just a matter of dropping that in. I mean, it's a very simple process to do. So let's say, for example, that you write a shared library in TypeScript, you write it as an NPM. It is directly consumable by your native script app. That's the way you'd want it. Or if you write it in ES5, that would also be possible to do a require on, as long as it's a common JS module. So I would say it's very easy for you to actually borrow stuff from a web app project and just have native script use it.
Cool. And the last question would be, what can we see live now in the App Store using this?
You mean what kind of plugins? Or?
No. The actual apps that use this in production right now. Are there any that you know that you use?
That's a good question, because they actually just released native script into a version that's considered more stable than it was before. So I'm not exactly sure if there's like a killer app out there. I'm actually going to have to owe you the answer here and check what apps are actually built by native script. But as I said, you don't see a difference whether it's built in Objective-C or built in native script, because it's going to turn into the same binary. So maybe there's a lot of apps out there already. But yeah, I'll definitely look that up and try to give some good examples of projects.
Okay, thank you.
Thank you.
Well, thanks, Chris. Now, everyone, please don't forget that Chris brought a few goodies for the audience. If anyone wants, please come here. We have now lunch. Please be back here at 2 for more sessions. We have restaurants all over town. See ya.